Alrighty, so yeah, I think I'll go. All right. I think perhaps allotted enough time for folks to find their way over here. So I suppose I'll begin. Hello, everybody. Hi. My name is Phillip Carter, as you can see on the slide. I work on Fsharp for Microsoft, and I'm here to talk about some cool stuff coming in Fsharp 5.0, which we hope to deliver sometime later this year in alignment with C# 8.0 and .NET Core 3.0. So lots of Microsoft version numbers just kind of floating around. And well, anyways, this one's 5.0. Anyways, this is sort of the main feature, and this talk is going to be a lot less about sort of how you use the feature and a lot more about just the design itself, because to be frank, we're still kind of in the middle of figuring out some of the more difficult design decisions, and so I think it's quite interesting to just sort of go through, like, from syntax all the way to, dealing with backwards compatibility, how a feature like this can actually get designed. So we'll be talking about a few things kind of in order. So first, I want to give a little bit of context on nulls as they are today in Fsharp, hopefully to give you a bit of understanding sort of the motivations behind doing this for Fsharp. Then I'll sort of go through the design, kind of the bigger, kind of high-level pieces. There's a lot of smaller details, like the spec is like almost 10,000 words long, so I'm not going to go through that entire thing. That would be far too much to go through in just an hour. But hopefully you'll have sort of a good idea of sort of what the thinking is behind the major design points. And diving into a few things kind of a little bit deeper. Then I'm going to talk about the representation of the metadata itself, which is like, we have this beautiful world in Fsharp, but there's actually has to be represented somehow so that other compilers can interpret what we emit, and we can read what other compilers emit, and sort of figuring out how that actually all works together. And that sort of leads into these things called nullability assumptions, which is sort of our way of how the compiler interprets certain things that it sees. And then there's just sort of a small little grab bag of kind of fun or perhaps not so fun little problems related to backwards compatibility and making sure that we don't break existing code but somehow still try to fit this concept of nullability into something, which creates a lot of interesting little problems to solve. So yeah, I guess we'll get started. So context on nulls, what are they all about? Well, if you're familiar with C# or Java or something like that, you're probably quite familiar with nulls and having to check for them. And there's a lot of that going on in that space. But a lot of Fsharp programmers say, well, I don't really worry that much about nulls because I have additional tools for dealing with them. And so long as I use those tools, I don't really have to think about them that much. So I want to talk sort of about that and sort of how nulls can also kind of creep in, even in light of some of those things that you have. Right? So null is... I'm actually going to make the claim that null is actually just fine by itself, right? You need to be able to represent nothing in a programming language. That's just a thing you have to be able to do, and null is a way that you can do that. I'm sure we can all agree that the concept of nothing is perfectly handled by null. It's just the problem is that it's implicit. It's not sort of in your face, right? Like if you have a string. It's said, like the type system says that's a string, but it's not actually a string. It's either a string or null, but there's no indication that you get that that's actually true, right? So you can have code that looks like this, where it's just a very simple, just valid Fsharp program, takes in a number and turns it into a string sometimes. But if you execute this program, you always get an exception at runtime. It always fails. And there's zero help from the compiler that you get from this. We like to think that Fsharp sort of has this tradition of letting you know that, oh, something is not going to work at runtime, or these things are not consistent, or something like that. But if you take this code, you write it in your editor, doesn't matter which Fsharp editor you have, you'll get no warning as to the fact that this is always going to crash at runtime. So this is a very contrived example, but I'm sure plenty of you have run into this problem in the past. Right? So to deal with this, Fsharp is not without tools, right? Most people are probably familiar with options. So rather than dealing with nulls here, if I want to represent nothing in this case, like if I want to try to parse an int from a string, I I can just wrap the value that I've parsed into an optional. And I can use the options none case to represent, oh, it can parse. And this is sort of a much better strongly typed sort of thing in terms of dealing with the concept of nothing, because then you have to pattern match to get the actual value out. And if you fail to account for all possible cases with a pattern match, then the compiler complains because it could fail at runtime and so on. And this is just something that once you learn how to do it and sort of place options everywhere in your code base, you can sort of eliminate certain aspects of null and not really have to worry about it. And the compiler is always there to sort of help you deal with the fact that something may not necessarily exist. So this is definitely a tool for dealing with null. That's pretty good. Another one is we are immutable by default with Fsharp. So I could assign something to be an actual string value, and at no point in the program's lifetime will it change, so long as I remain immutable, and that's by default. I have to be actually explicit about mutability, and by doing that, it's almost sort of like a code smell that Fsharp programmers are sort of used to dealing with. Oh, I had to make this mutable. It could change out from under me at any point in time. I need to be really careful with this. Or maybe they may even say, oh, well, I should perhaps rethink how I'm actually constructing things around here so that things can't change out from under me. Whereas, if you compare that with C#, for example, things can always change out from under you kind of by default. And so this is something that does make the problem a lot better in Fsharp. And then also, speaking of reference types, if you declare a reference type in Fsharp and then you try to do something like a null check on it, well, you can actually get a compile error saying that this thing, such as my class here, does not have null as a proper value. That's because Fsharp declared reference types by default do not support null as a value. So, again, so long as you're just sort of in this nice little Fsharp world, you can construct various things and use different tools in the language to sort of not really have to worry about nulls that much. But the world's a little bit more complicated than that, and you don't always get to live in a nice little world that you can construct for yourself. One example is using the exact same code as before. You can apply this attribute called allow null literal to a class that you declare. This is if you need to work with an API that actually accepts null as a proper value. Well, you couldn't do that in the previous case, but you can do that here. However, at least in this little contrived example, I only needed nullability in one spot, but I actually kind of got it everywhere now. Because instead of being able to say, oh, here's just this one place where I need a null to exist, but I don't want nulls anywhere else, so I'm going to put this attribute on there. Now, anywhere that I define an instance of this class, especially if it's a mutable instance, I can modify it and assign it to null anywhere there. So nulls can sort of creep in kind of subtle ways like that. Another interesting one is the CliMutable attribute. This is something that plenty of people use with Fsharp records if they're using them to work with like an object relational mapper or something like that. Well, an object relational mapper needs to be able to change the values of something all the time. And string today can certainly be assigned null. So throughout your application's lifetime, you could have an actual value inside a string. You could do something like call.length on it and be totally happy because you're saying, ah, yes, I'm using an Fsharp record type. The whole thing has been there, everything's immutable. Of course, I can be totally safe with this. Well, if you use CliMutable, you can't use that assumption anymore. But the problem is if you're used to using record types all over the place and you sort of make these assumptions that, oh, this thing's not going to be a null, I can just dot right into it. That's not going to hold true if you do this sort of thing. And so again, that's sort of like a little subtle way that things can get in there. But then finally, there's just the general problem of .NET interop. I would probably say that the majority of Fsharp programmers that I know have to interoperate with some other .NET library or the .NET BCL or something like that. So this is code from the Fsharp tools for Visual Studio. This is just a little routine that colorizes a document, makes a bunch of API calls. So there's a bunch of code there, but what's interesting here is we're mixing .NET reference types with Fsharp declared reference types. Right? Because we have classes that we've defined in our own code base, and we use those, like this thing called the Fsharp checker and things like that. Well, the Fsharp declared ones are non-null, but the .NET ones can certainly be null. Right? So there's actually two places in here where there might actually be a null reference exception just waiting for us, and we haven't accounted for it. Now, we haven't actually encountered one of those yet because we happen to know that the underlying system never passes us one of these null documents, but there's nothing in the type system that prevents that from happening. Yet we're sort of lulled into this false sense of security where, oh yes, we're working with all this nice non-null stuff in F#, but it's mixed together with things that could absolutely be null. And like in this case, this is well-tested code, but we never tested the if checks for what if something is null? Now, we could certainly add some unit tests for that and say, yes, we accomplished the problem, but the next time we write something like this, we may not account for null again, and so things could potentially blow up. So nulls still exist in F#. I would say that we certainly have more tools to deal with them today, but they can still creep in oftentimes very subtle ways, and those can be very frustrating because you're like, well, I'm supposed to be using this safer language. Why am I not getting this null safety that I get in some cases but not other cases? So hopefully it gives a little bit of motivation for why we want to do this. There's actually more motivations that I'll talk about later, but this in particular is just sort of from the F# perspective. So with that in mind, I want to talk a little bit about the design itself, sort of saying, okay, there's all these little places where nulls can come in. How do we address that in a way that plays to the strengths of the language? So as the slide says, due to time constraints, this is absolutely not comprehensive. The spec is very, very big. I'll have a link to it at the end. You could take a look if you're very interested in that sort of stuff. But I will cover some of the major points. So there's a few goals with this. So first, we want to distinguish very strongly between a nullable reference type and a non-nullable reference type, right? A string versus a string that could be null. And we want to say, as far as the F# type system is concerned, these are kind of distinct things. Now, for backwards compatibility reasons, that's not true, right? You need to be able to compile code and run code that with the F# 5.0 compiler that you could with the F# 4.5 or the F# 4.6 compiler, 4.1 or something like that. That's just basic backwards compatibility stuff, but we do want to be able to distinguish in a way that we can warn you. Similarly, we want to keep existing code going, but we do want to sort of discourage you from using nullable reference types because it is sort of this thing that can just put nulls there, and if warnings are emitted in all sorts of little places, then you'll perhaps be discouraged from doing that and sort of say, oh, I'm going to rethink what I'm doing right now and try to find a way to make things non-null. There's a few helper functions and patterns for pattern matching that we'll provide as well that kind of makes the transition from nullable to non-nullable a little bit easier. And there's various degrees of compiler analysis that'll exist there for when you are working with nullable reference types, and you just want to make sure that you're accessing them correctly. Code is usually the best way to understand stuff. There's a little bit of different syntax here. So the first three values that are declared here are explicitly annotated as two of them as a nullable string and the other as a non-nullable string. And so the first two work fine, right? You can assign null to a nullable string, and you can assign a string to a nullable string. But the third one, you try to assign null to a non-nullable string type, you'll get a warning. Now, this will actually compile and run just fine, because you can do that today, and we don't want to break the code that runs today. But we still want to emit a warning. Similarly, if you try to just dot into something that is a nullable string without checking for null, then you'll get a warning. And so if you want to have sort of an alternative to that, here's, at the very bottom, there's pattern matching where we have this pattern called the non-null pattern that basically binds what you have there to a non-nullable string. It actually succeeds. Then you can dot into it, and it could be totally fine. So there's a few more things that are here. So kind of the first example is using pattern matching to bind a non-null value and then be able to dot into it. In this case, you could just have a function called null_argcheck, given a nullable string, produce a non-nullable string. And then if you dot into that, it's totally fine. Whatever that function does, who knows, right? It just works with the actual type system itself. Another interesting thing to note, the array signature here is kind of interesting. It's kind of ugly, and that's honestly that's just intentional, right? If you have a bunch of you have a bunch of nullable stuff. It's not really that nice to annotate everything with all these question marks and stuff, like this question mark bracket bracket thing. It's much nicer to just have string bracket bracket. And so if you can sort of say, oh, well, I actually don't need nulls here. I don't know why I'm doing this. Then that's sort of a benefit there. And so This last example is kind of what some more highly generic code could look like if you want to be generic over certain nullable types. Well, non-nullable and then producing nullable types. And so there's a bit of stuff there, but it'll sort of come naturally to you as you start working with it. So as I mentioned, there's going to be some helper functions and patterns that can sort of help out with this. Some basic functions like, is something null? You can sort of assert that something is non-null, and it'll probably throw an exception at that point in time, but this is something that comes in handy later. And then there's some active patterns that we have that you can use in pattern matching, because pattern matching is sort of the main control flow that most F# programmers have. You work in terms of types, you determine the shape of the types, you dispatch certain functionality based on the shape of the types. Well, we want to play into that, so we can use active patterns to be able to figure out if something is going to be null or non-null. And that actually works out quite elegantly with code today. So Another interesting thing that needs to be happening, because F# programmers, and well, frankly, all programmers want to be generic over stuff, there's a new generic constraint that's being added. Because we already have the when t is null constraint, the when t is a struct, meaning a value type, when t is not a struct, meaning a reference type. And those exist today just fine. But we need to be able to say, oh, well, there's now a notion of reference types and non-nullable reference types. So it's nice to be able to have a generic constraint of saying, oh, this thing is not nullable. So the semantics of that are fairly straightforward. There's just a little distinction between something that is F# declared versus something that is not F# declared. Because F# today, as sort of I talked about, you can declare a reference type that does not have null as a proper value. And if you try to use it as if it does, it's a compile error today. So we can actually afford to have a compile error for similar things. If you try to instantiate an F# type that does have null as a proper value with this not null constraint, that is a compile error, and that will be consistent with the way that you do things today. However, if you do it with just a regular old reference type like string or something like that, it's a warning rather than an error, and that's just for backwards compatibility reasons. Now, you could certainly tune that warning to be an error if you'd like, but that will not be the default, because we don't want to break people. So speaking of pattern matching, there's sort of a slight change to the way that you'll do stuff here. So there's this example right here, trying to take the length of a string. You have the null pattern, and in the case of it's null, we return -1. Then we have this non-null pattern that you sort of saw before. You can actually use that anywhere, not just at the end. I just kind of have it at the end because most F# programmers kind of tend to do that. It's a bit more of an extensible option, which is why I show it first. It's the sort of thing that we're still kind of noodling on the design on a little bit, but we think this may be sort of the preferred way to express that something is not null via pattern matching. Now, in this case, you actually don't need to do that. If the null pattern is the first, in pattern matching, then you can actually just bind to a variable pattern, as you have there with s, and then we know that s is actually just a string instead of a string question mark. And this is consistent with existing pattern matching rules. But it gets a little bit more complicated if you do column-based pattern matching, meaning pattern matching over tuples. So in this case right here, you might think that this particular function is fine, but it's actually not. It'll produce warnings on S1 and S2. And that's because the analysis of sort of the columns themselves is done after we have performed our basically the type algebra, right? Before we've finished type checking. We finish type checking and then we do column analysis. And so mixing those two things together, we basically say, oh, well, S1 and S2, we can't really guarantee at this point that they are non-nullable, so we have to assume that they are nullable. And this is just sort of a quirk in the existing language design that we may find a way to work around, but it's quite an invasive change. And doing that has the potential to break a lot of scenarios that we're kind of not really willing to take the risk on at this point. This is really just kind of going to depend on feedback that we get, and as we use the feature more ourselves and try to figure out the works. We think the ergonomics of using the non-null pattern are still fairly consistent with the F# language design, and this does allow us to not have to completely reconstruct the compiler to be able to do this sort of thing. But so if you're pattern matching over tuples, you will have to use the non-null pattern today. And so, yeah, this is one of these things that is kind of half set in stone in the sense that it's risky to change, but at the same time, we're kind of aware that it's kind of not ideal, so we'd like it to be different, but I guess we'll see. Playing into the Fsharp type system with nullability is actually based off of just a few simple rules. There's some fancy words here, but they're actually pretty straightforward, right? There's this notion of type equivalence, where we actually determine if, like, if I pass an int to this thing that takes in a string, well, today that obviously doesn't work, right? That's because int and string are not the same type. That relation is defined in the compiler, right? So we need to have type relations now for distinguishing nullable and non-nullable reference types. So for backwards compatibility reasons, you'll see there's a fairly straightforward pattern here where nullness is ignored for most things. Actually, it's basically completely ignored, but we do emit a warning on certain mismatches. So if x and y are nullable string and non-nullable string, well, you're still mixing things that are kind of different, so we want to emit a warning, but we'll still allow the code to run. Type subsumption is basically just the object-oriented, is something a subclass of another thing, and a nullable thing is not necessarily a subclass of a non-nullable thing. Now, today that works, but tomorrow we do want to emit a warning on that. For method overload resolution, it's fairly straightforward. If you pass in something just takes in a string and you pass in a nullable string, we'll emit a warning on that, but it's still fairly ignored. Abstract slot inference is that's just determining like if we satisfy an abstract member, like something defined in an interface or something like that. And so all fairly straightforward. And then duplicate method checking, we just ignore it altogether. If you declare duplicate methods, that just doesn't work. So we're not really going to touch that. But these sets of rules actually drive all of the semantics for how the Fsharp type system sort of treats nullability. Right? So for example, if you want to mix nullable and non-nullable, things get a little bit complicated. So for example, this x's, y's, and z's bindings that we have here for an array, a list, and a sequence, you might think, oh, well, these are going to be nullable string array, nullable string list, nullable string sequence. That's actually not the case. Because the first element in the collection is the one that actually determines what the type of the collection is. And so an empty string is a string, right? It's not a nullable string. It is just a string. But then we throw a null in there, and we say, oh, well, but the type of this collection is a non-nullable string. Now you're putting a null in there. Those things don't match up. Now, the code will still run, because it runs today, and we're not going to break that. But we will emit a warning because of that. So the solution to that is to just add type annotations. And it's kind of ugly, but that kind of does get to that point of, do you really need to have nulls in there? And if you do, then you're still going to have to do this. But oftentimes, at least we found in running this version of the compiler against our own code base, we had plenty of cases where we were inserting nulls into things that we just didn't even need in the first place. And so it was actually kind of nice to see that and say, oh, we can actually simplify our stuff. So that's sort of the algebra of the types that we have there plays into this. And this is one of the cases that you'll likely run into very quickly. Additionally, nullability assertions, which I had mentioned a little bit before, come into play here because we can't associate just sort of arbitrary functions that return true or false depending on if something was checked for null with the nullness of something. That's, the compiler could do a little bit of tracing if we wanted to, but that quickly enters the realm of sort of like potentially infinite compile times. And we're going to take the assumption that most people don't want significantly increased compile times as a result of this feature. So one of the things that we'll do is there's the non-null function here that you'll have to call and sort of say, no, I'm sort of asserting that this is actually not null if you wanted to check for things like this. And then you would say, OK, now this is kind of redundant, right? Because we know that this myIsNull function actually does check for null, and yet we still have to assert non-null. And so that would say, OK, well, could I use something else, like maybe perhaps pattern matching with the non-null pattern and simplify this in the first place? So another interesting one is the OBJ type, which is kind of interesting. We actually decided we're going to just ignore nullability for it altogether. And the reason is because whenever you get an OBJ in Fsharp, you've thrown out just all type information anyways. It's just the most basic thing that you can have. And so I'm sure plenty of you have encountered type inference inferring something to be OBJ and then warning you saying like, hey, you're trying to use this stuff as if it has a type, but this thing is actually OBJ, and so it has no type, so maybe you want to rewrite this. So it's kind of pointless to add nullability semantics to this thing because since there's no type information for us to really do anything with, distinguishing between OBJ and nullable OBJ is kind of a moot point. So that was an interesting finding. Like we sort of actually initially thought, oh yeah, we're totally going to have to do that. But then when we sat down and said, okay, how's this actually going to work out? Well, there's not really any null analysis to do once you have OBJ. So that's kind of a fun little quirk. And then finally, another one, you can have nullable value types in Fsharp today, and there's no special syntax for them. So we figured this is perhaps a decent opportunity to try to align the way that we handle nullable value types with the way that we handle nullable reference types. And so it's fairly likely that we'll be able to have a syntax like this, similar to the existing C# syntax, int question mark, and you could pattern match on it and sort of have the same sets of rules applied to nullable reference types, except they're value types. And so this is something that isn't quite locked down on in the design yet, but we'll probably get to it at some point. I'm sure there's going to be a few little dragons along the way, and so we'll have to revisit what we thought we were going to do. But this is sort of what we're thinking things could potentially look like. So that's sort of the whole, from the F# world, okay, this is how the type system is going to be a little different. These are the type relations. We're going to have some functions, some patterns, all that sort of stuff. But that's all just, it's sort of trying to be consistent from F# to F#. But there's another language doing this too, called C#. And it would be nice if F# could produce metadata that C# could consume. And it's certainly nice if C# produces metadata that F# can consume. And so that's exactly how this happens, actually. And the way that it's done, actually, under the covers is all just these attributes that are applied to everything. And so that allows it to be backwards compatible because older compilers will see that metadata that they don't understand, and they'll just say, oh, I'm just going to throw this away. So it allows you to represent something like a nullable string, but an older compiler would just see a regular string, and there's no crazy stuff under the covers. So some of those attributes are rather interesting. The first is the nullable attribute itself. This is the one that the compiler inserts for everything. So you saw those little string question marks, things like that. There's no notion of a string question mark in IL, for example. It's actually just an attribute applied to a string. And so the compiler knows what to do when it sees that. So this attribute looks like this. It takes two constructors. One is the empty constructor for kind of most things, and then the other is a constructor that takes a bool array. And this is used to represent nested types. So what I mean by that is, say you have a resize array of nullable string, right? So the resize array is non-nullable because there's no question mark there. But the string is nullable, so there is a question mark. So as far as what that gets translated into, there's actually an array where the first element is false, representing the outer type, and then the second one is true, representing the inner one. And so for arbitrary nesting that you have going on inside of there, you just sort of have that same size of array with true, false, true, kind of whatever it actually ends up being. So the F# compiler will see this, and then it will say, okay, I know that I will assume that resize array is non-nullable, and then I will treat the underlying types inside of it as nullable. So sort of how that stuff all gets encoded under the covers. So I had mentioned compiler analysis, and there's this function where you may have to assert the non-nullability of something. And how we said, oh, well, we can't associate an arbitrary Boolean returning function with the nullability of something because that could just be too complex for the compiler to trace everything. However, you can actually apply certain attributes to affect compiler analysis to basically allow it to make a certain assumption. So that same function could have, say, the not null when true attribute applied to the top of it. And then the compiler could read that and then say, oh, OK, well, I know that if this succeeds, then whatever was passed in is not going to be null, so I can assume it's non-null from that point forward. That's sort of a way that we can get around that. And so this is something that's going to be helpful for library authors, framework authors, that sort of stuff. Ensures not null is sort of the same thing as these not null when true, not null when false, except it's about assertions. So if you have a function or method or something that asserts something, throws an exception, ensures not null. If it throws an exception under the covers, then that's the appropriate attribute to apply to it. And then the asserts true and asserts false. I personally think it would be most useful for test frameworks. So if you want to assert the nullability or non-nullability of something and you don't want to get a warning with that, well, the test framework can just judiciously apply this to the appropriate pieces of that framework. And that will make sure the compiler doesn't throw a bunch of warnings at you. So those are also pretty neat, but this one is my favorite one, the non-null types attribute, which is kind of big. There's a lot of different places it can be used. One of the most important ones is the module level, so you can apply that to a particular assembly. This basically says, for a given scope, nullability is either a concept or not a concept for that scope. And so what I mean by that is there's actually three cases here. But so there's nullability as a concept is a way of saying, hey, we distinguish between nullable and non-nullable reference types for this scope. And if it's set to false, we explicitly do not distinguish between the two, just like it is today. But the interesting case is actually if there's no attribute whatsoever. That's what are known as null-oblivious semantics. And so that's kind of an interesting thing that leads into these things called nullability assumptions. Because I had said the word assumption a few times, right? Oh, based on this attribute that's applied here, the compiler can assume whatever, right? Well, if you have non-null types true, we can assume, okay, well, for that scope, we can assume that there's a we're going to distinguish between string and non-nullable string, and this is just something that people will be happy with because that's actually there. But what if there's no attribute at all? That's where things get a little tricky, right? So there's the three choices, distinguish or choose not to distinguish. And then there's a third, which is make no assumption in either direction, right? So you might think that that's equivalent to not distinguishing. But it's subtly different, which is where I think it's a little, it's kind of fun to think about, right? So what that means for F# is if we have no information whatsoever, that means if we have a value and we assign it to something that is a nullable reference type, we consider it to be nullable. But if we assign it to something that is a non-nullable reference type, we consider it to be non-nullable. Right? So you could have code that kind of looks like this. You get an oblivious string. If it's assigned to a nullable string, then we say, OK, well, we'll treat it as if it's a nullable reference type from there. And if you assign it to just a string, we'll treat it as if it's a string. But there's an interesting question that arises from this, because most F# programmers don't annotate values like this. They use type inference. And so what if S is not annotated? Right? If I say let S equals oblivious call, then what is S, actually? Is it nullable? Is it non-nullable? From a safety standpoint, you might say, oh, well, it should be non-nullable. Or sorry, it should be nullable, right? Because you can't assume that it is non-nullable, and we should err on the side of safety. Well, it's a little bit more complicated than that, actually. And this is where a kind of difficult design choice comes in. So there's actually a case for being null-oblivious and a case for being nullable, right? So in an oblivious case, even though this feature is sort of in a way meant to give you warnings, if you're porting a bunch of code that you know is littered with this stuff, and you don't really want to, and it's these older assemblies that don't have the attributes, all that fancy stuff. It's just things that are coming in. Some people may say, oh, well, I don't want to deal with that right now. I know how it works today. I will slowly piece away the problems with it. And if we go with null oblivious semantics, we actually are consistent in the sense that if there's no indicator in the metadata, then we can't make an assumption, so it just kind of is what it is. But the downside is, well, you do get less warnings, and you can get more potential null reference exceptions. And actually, you can write entire programs that are oblivious due to type inference, right? If you just have nothing but values that are generated from oblivious calls, and As you know, in F#, lots of things are just sort of figured out by the type system, and then they don't actually get sort of assigned to a nullable or a non-nullable type. Then that's kind of a weird state for the program. On the other side of it, you don't have that problem if you assume that something is going to be nullable. And you can get more warnings, and if that's the thing you truly want, you'll definitely get more warnings with this sort of stuff. And if you account for them, you won't get as many null reference exceptions, or at least possible null reference exceptions. But the downside is if you're inundated with hundreds, perhaps even thousands of warnings, that's kind of a little overwhelming. Like I think most of us, when we see a warning, we know we want to squash it out. But if we see 1,000 warnings, that's a little bit more different. It can be a little overwhelming sometimes, and sometimes people may not want that. And it is not actually logically consistent, because if no information means we can't make an assumption in either direction, if we go with sort of a nullable assumption, well, that's making an assumption about something. So there's not really a perfect approach to this in my mind. And I think this sort of gets to the core of language design, is you end up in this sort of situation where there's two paths you can go, and there's no obvious one to take. Right? Some people are going to say, oh yes, it needs to be oblivious. I'm personally in the camp of saying, hey, we should probably assume that it's nullable. And I imagine a lot of F# programmers will probably feel that way. And so, although we currently do have oblivious semantics implemented right now, it's still very sort of early in the design phase. We're still figuring out how this thing feels on our own code bases, and we're looking to get a lot more feedback from people on this. Because if a lot of people say, hey, this doesn't make any sense to be oblivious. I like more warnings because I want to squash those warnings, because I'm an F# programmer who wants to know when something's not going to work. And if it's not going to work, well, I'm going to fix that right now. And I'm not going to progress until I can do that. So the current design is not set in stone yet. But it's something that we wanted to explore and sort of see how it worked. So that's sort of one of the interesting pieces that I think is definitely up for discussion, and also up for redesign, really, just sort of depending on how people use it and how they feel about the feature. So kind of one of the last pieces of this is, we adjusted the F# type system. We've added all these little helper functions and patterns, and we have this weird semantics with oblivious versus maybe not oblivious, and maybe we're not really sure. But there's still a bucket of just all this existing F# code that does stuff that is a little bit different with knowable reference types in there. And these are just things that we sort of discover over time as we think about this feature and sort of design it and test it out on more and more code. So if you've ever used default values in F#, you could certainly do something like this, right? I have a default value of string. We know that today the default value of string is null, right? Well, this is actually a contradiction, because default value implies nullability, but the string type says that this is non-nullable. So this is perfectly valid pre-F# 5.0 code today that has to generate a warning. There's no way to be correct with the feature and not generate a warning. So this is kind of an unfortunate side effect, if you will, because this is something that, this isn't new code that you've done. This is existing code that we can't really fail to warn in this case, because then we're sort of lying and we're saying, oh, this type signature that you have here means nothing. That's sort of strange. And, we may revisit that decision, but it's still just this little quirk. Similarly, the ClineMutable attribute that I had shown earlier does the exact same thing. The ClineMutable attribute implies nullability for things that are underneath, right? An object relational mapper may be saying, oh, the database value is null, so I'm going to set this value to null because that's just what the database value is at this point in time. But the type string says that it's non-nullable, so again, this is perfectly valid code today. There's absolutely nothing wrong with writing code like this today. You may have to have a few more null checks if you want to be truly safe, but that's now going to produce a warning, and we can either produce a warning or not produce a warning. If we produce one, then this was valid code that is now saying, blah, can't do it anymore. But if we don't produce a warning, then we're sort of lying to you. So it's sort of this weird sort of quirk that you can't really get around. Past decisions that you have to live with if you care about backwards compatibility, which we do. And then the last one, this one is truly great. I love this one absolutely to death. So you're probably all familiar with option types. Here's just a very simple routine that produces an option based on a flag. Gives it a string value, otherwise it gives it none. This actually compiles into this. This routine here, this is sort of the equivalent C#. You'll notice return null at the very end. This is the great irony of F# options is they're actually implemented such that the none case emits as null. So the F# option type, which is designed to deal with the case of nothing, has to be a nullable reference type if you read it from C#. But if we change that, it's a massively breaking change, right? Because if it's, we don't really have a great resolution for this right now. So this is this incredible quirk that when we thought about it, we said, we just kind of rolled up into a ball and just started crying because we're like, we built this thing that is like this sound system for dealing with the concept of nothing, and now it is emitting as the thing that we're telling people to avoid. I imagine the majority of F# programmers who do C# interop are not particularly going to be flummoxed by all these options coming back as possibly null. And I think most people are fairly common with the idea that you sort of have your F# type stuff, and then you create little C# easy to consume wrappers so that C# can consume it, and you could probably get around this. But yeah, this is just a real wart that is probably just going to have to exist in the language. And again, if we change this, this would be a breaking change, and we simply can't do that because that's sort of one of the core tenets that we have as a language. So that kind of makes you think, like, okay, so why even do this, right? If something as fundamental as the F# option type for dealing with this sort of stuff is going to emit as a nullable reference type, like that's just silly. Well. It really is all about trying to make .NET a better place. Like, it's the nullable reference types feature for F# and for C# it's not perfect. It's one of those things that it'd be great if it could have been all implemented in both languages at the same time at the 1.0 version, and then we'd all be happy. We'd have this perfectly sound way to deal with it. But here we are 15 years later and trying to get it in there. But it's I guess you could say it's all in service to a greater cause, because I truly think that even though that it's warnings instead of errors, backwards compatibility, there's these weird little things that you kind of have to deal with. I mean, fundamentally, you're going to want to get rid of all these warnings. And by doing that, you're going to have less nulls flowing through your code base. Library developers are going to stop accepting nulls in certain parts of their APIs, and they're going to stop emitting nulls that you have to deal with. And I can imagine after this feature has been out for C# and F#, 5 years, after that, I can imagine a world where a large chunk, if not the majority of .NET programmers just stop really worrying about nulls that much. The notion of, oh, the application crashed again, oh, what is it? Oh, null reference exception. The junior developer who didn't really know to check for null in this weird little edge case or something like that, it just won't really be a thing. And it's sort of this, I mean, it's a feature, kind of a non-feature in a way, like where the notion of nulls is just kind of being tucked away in a little corner that it's very visible when you have to deal with it, but it's not something that's forever present in your world. This is something that, to be a part of this, F# has to also implement this feature because there are a lot of components and a lot of libraries written by F# developers that can emit nulls and can accept nulls today if they have C# consumers. And so we want to just push .NET into this newer place where everything is just safer and you're just not worrying about these little edge cases as much anymore. And to be a part of that, you have to sacrifice a few things like, there's these little imperfections with the option type that I just mentioned and things like that. But at the end of the day, there will just be less nulls in general. And so we think it'll work out pretty well. At least we hope so. So if you're interested in this sort of stuff, certainly on the nulls feature, there's a few links here. The first, this F# nulls link takes you to our spec today, which, as I'd said, it's about 10,000 words. There's a lot to read. There's a lot of code samples. There's a lot of fine little details. There's a lot of stuff where things are not quite figured out, where you can look at it and you can say, oh, here are like 3 different approaches that we might take. We're not quite sure which one we're going to do yet. The prototype does X, but we could also do Y or Z. That's just sort of the almost sort of messy nature of language design, is just working out all these little kinks and trying to figure it out. If you're perhaps not interested in reading a 10,000-word spec, but you are interested in language design in general, there are the Fsharp language design repo and the C# language design repo, where there's a lot of discussion, oftentimes intense discussion, about potential things that could be implemented in the future, or about things that are on the docket to be implemented, but there's still some open design questions. And there's also a lot of things where a certain feature, you may read about it, you may read the spec, and you say, oh, I'm not really sure if this accounts for this particular thing. And you could submit a pull request and say, hey, here's an edge case that may not be accounted for in the spec, and I think this is really important to get. And that is sort of the heart of language design right there, is just thinking about something, working out all the little problems before it actually gets implemented. And so hopefully this talk gave you a little bit of insight into sort of what that all means. Certainly from the F# perspective. I know that the C# side, it's a little different, but it's still sort of the core set of problems. Here's this abstract thing we want to do. Now let's piece that together, pull that out into the million little details that it actually means, and try to figure out a way to keep it all consistent. Yeah, thank you very much. And I encourage you all to go check out this stuff, and hopefully you'll submit your own RFC to one of these repositories at some point. And yeah, have a good rest of the day.
I have 2 questions. The first is, you said there's an attribute that makes a specific method mark the parameters that are passed to it as non-nullable. Like as if they check and throw a not no exception. Will it be similar to the preserve attribute? Because the preserve attribute can be any attribute that you define, and then the compiler just checks for any attributes that are called preserved attribute, or will Microsoft provide the system induction and is not attribute?
I think today those attributes are in system compiler services interop. It's a particular namespace. I think I actually had it. There's like an interop namespace that we add things. Yes, at least that's the current idea. I just want to find it so I can bring it up for you. Yeah, system runtime compiler services. So there's, like for example with the span work, there was there were some attributes that were put in there for these things known as ByRef-like, and so.
Mark a method as checking if
yeah.
They are also there.
Yeah, they'll likely be there when this thing ships. At least currently. I expect that to actually happen though. Yes.
The other thing is, I don't know if there's a technical limitation to that. Actually, I don't know. But doesn't it feel a bit weird that we now have 2 ways of expressing nullability?
Mm-hmm.
You have the OptionType, which we are already used to using, and then if you have, say, nesting, you can't really flatten it in a simple way.
No.
Like, it feels a bit odd. And are you trying to do something to bridge this gap? Maybe?
So we'd thought about it quite a bit. In fact, we actually wanted to do that. I'll go all the way back actually to that bigger code sample from our code base. We actually got spooked when we looked at our own code base. So basically, like this routine is, I think, like maybe 14 lines of code or something. If we were to sort of coerce, say, this document type into an optional, so say, oh well, this document type is a nullable document type, for example, and say, oh, that's actually an option, so you have to account for it as if it were an option. That would actually be a source-breaking change in 2 places here. We have other code samples where it's up to like 50 source-breaking changes for a given file. It's actually kind of crazy. It actually made us quite sad, actually, because we have, I would say, a rather consistent system for dealing with nothing with options. Unfortunately, it would be just too massive of a change. And so we thought about something like maybe a code fixer that could try to sort of add pattern matching in places and things like that. But I think it ended up being something that we couldn't really account for all possible cases, and we just have sort of this bug tail of people saying, oh, I tried to compile my code and now it doesn't compile anymore. Thanks, Microsoft. And yeah, we sort of got spooked by that, and we said, okay, well, at the same time, it's still, from a backwards compat standpoint, it's still not sound, right? Like, you know, if you have reflection involved and you have, you know, you just suppress warnings instead of actually dealing with them. You know, the code still continues to run today. We're sort of kind of hedging our bets on people dealing with warnings. But I would say that we haven't formulated guidance on this yet. My initial thoughts on guidance would be that for F# programmers, you should just continue to try to use options as much as you can. So maybe you get a nullability warning for something, but instead of using the nullable stuff, you may actually just say, oh, I'm just going to actually construct an option out of things. I think we're still at the point where we want the community to try to lead us towards what the guidance needs to be. Now, we have our own thoughts on how to, you know, what you should use and all that sort of stuff, but you know, we only have a limited number of code bases where things may feel right, and so we are going to lean a lot on the community when we have a preview of this feature coming out to really say, oh, I deal with it in these ways. You should consider, you know, documenting these ways to deal with it and that sort of stuff. So yeah, it's imperfect, and it made us sad that we couldn't, you know, treat them to be the same. But yeah, unfortunately, that was just sort of what happened. Yeah.
Was it a C# 8 that forced your hand?
In a way. So, well, I mean, I guess the thing is, the way that things are being handled in C# is honestly, I think, really the only way that you could do it for C# for it to work. And so interoperation with C#, I mean, we could sort of do anything we want at the interop layer, but just keeping things consistent from the F# side and making sure we don't break things was too big of a risk. And then there was also the problem of, oh, we interoperate and we transform into our own system, but then we need to somehow translate that back into what C# has. And so I think we just sort of said, okay, well, for better or for worse, we're a .NET language. We might as well just play with the system that's being built up and being tested by a larger group of people. And you know, that system itself is going to be improved over time, and there's going to be little learnings that we get from a very wide number of developers, and we can apply those to F# as well, like with subsequent updates and things like that. So, yeah. Let's see. Any other questions? No? I guess I will say, as sort of a little final thing, well, it's, I guess, slightly unrelated. F# 4.6, the one coming before 5.0, is going to be coming out soon, and it won't actually have any of this, but we do sort of encourage you to look at that if you can as well. That'll have the anonymous record types inside of it that, huh? Do you have a date? Well, the date is going to be when Visual Studio 2019 ships as a GA, so it'll certainly be this year.
We're waiting for Nominal Types forever.
Yes, it'll definitely be there. It's fairly baked. There's I think I managed to log like one bug on it, and that was it. So it was to deal with type abbreviations and anonymous records, which is kind of a weird thing. But we don't have a plan yet, like a concrete plan for shipping this as a preview. Now, there's certainly, you can build the compiler from the repository and it all works, but we do want to you know, ship a preview of this inside of a preview of a .NET Core SDK and give people a chance to really try to bang on it and see how that goes. So yeah, well, that's about it. Thank you very much. I'll be around sort of for the rest of the day and the rest of, you know, the conference if you want to ask questions about F# and this feature, other features, things like that. Hopefully I'll be able to give you good answers. Cool. Thanks.